morning friends, I am Ms.K.Shenbaga Bhavani from Department of Computer Applications, SFR College, and welcome back to the programs. In today's program we are going to see about doubly linked list. So far we have seen about singly linked list. So in singly linked list there are so many advantages and disadvantages. Okay. So then how to overcome that disadvantages, we are going to see about doubly linked list. In doubly linked list we can overcome some disadvantages in singly linked list. In singly linked list so far we have seen it can travels only in one direction, but in doubly linked list the main advantages is we can traverse the nodes from both direction, that is from forward to backward. This is the main advantages in doubly linked list. So let us see the content. So basically in doubly linked list it is nothing but a normal data structure. It also consists the same as of a singly linked list set of nodes. Then it contains a value, and here we have a 2 pointers. So first pointer it will point out to the previous node, and the second node pointer will be pointing to the next node. This is the main concept of doubly linked list, that is we can traverse in both directions. We can go to next and we can traverse to previous also. So main advantages is we can traverse the nodes in both directions. So as per singly linked list or any other data structures, the normal operations only we have doubly linked list also it will be having. So that operations include insertion, deletion, then traversing, searching. These are the basic operations we are going to see in doubly linked list. So representations, and this diagram represents the doubly linked list. It's nothing but, as I already said, it contains three divisions. First one it will be containing the previous node, second is a main data, next is the next node. In data we will be having a data, previous node we will be having the address of the previous node, next node, in the next node division we will be having the address of the next node. So these are the representation, this is the representation of doubly linked list. So this is a basic structure. Then we are going to add or delete or traverse or search any node in doubly linked list. So basic operation, as I said already, we can traverse in doubly linked list. Traversing nothing but we can visit all the nodes from starting to ending and from ending to starting. So next in searching is nothing but we can search any node in doubly linked list. Next, finding the length of the doubly linked list. We can find the length, as usual we can find the length of the doubly linked list. So we can go for first we can see about the traversal in doubly linked list. Traversal is nothing but visiting a node. So it's already said doubly linked list is we can travel in both direction. So we can traverse in both direction, that is to forward and from backward. So first in forward traversal, first we have to initialize the pointer of the head. Okay. So from first in pointer head, next we have to, if the pointer is null, not null. So if it is not null means, so the list must not be empty. So if the list is not empty, we can visit the data at the current node. So after visiting we can move the pointer to the next node. So the same process will be repeating until all the nodes are visited. So this is a forward traversal. So next we can go for backward traversal. Backward traversal, so first we have to initialize a pointer to tailor. Tailor is nothing but end of the linked list. So if that is not null, same, if it is not null we have to visit the data at the current node, then we have to move the pointer to the previous node. So backward traversal is nothing but we can traverse from ending of the doubly linked list. So these are the two kinds of traversal in doubly linked list. So next we are going to see about finding the length of the doubly linked list. That is finding the length. We can find the length of the doubly linked list. The process is very simple. So if the list is not empty, we can find how many nodes are there in doubly linked list. For that we have to start at the head of the list. So next traverse through the list counting each node is visited. This is same as of traversal. So after each node is visited we can move forward until the end of the doubly linked list. So after visiting each node we count as number 1. So after next count we have to move to the next node. So after traversing or visiting each node, the count will be incremented. So till n we can find the length of the doubly linked list. So next we are going to see about inserting. So inserting in doubly linked list, inserting can be done in 3 methods. That is, it can be done in beginning, or it can be done at end, or at any specific position. Okay. So these there are 3 types, 3 methods in doubly linked list. First we are going to see the insertion at first beginning. So if we are going to insert in beginning, it is a simple process. Just we have to create a node with the given data. Then for that data, see in diagram, if we are going to create a new node, so we have to set the previous pointer to null. So the new node of the previous will be set to null. Okay. So next, set the next pointer. So next pointer will be pointing to the next. In the diagram you can see the next will be represent to head. Okay. If the linked list is not empty, if the list is not empty, we can update the previous pointer of the current head to new node. So return a new node as the head of the updated linked list. So the new node will be inserted at the beginning of the doubly linked list. So this is the first method of insertion, that is at beginning. So second method, we can insert a data at ending. So same method, first we have to allocate a memory of a new node and assign the provided value to the data field. So next what we have to do is initialize the next pointer. So the created node, that is new node to null pointer. Okay. Here comes the 2 options, if a list is empty, if a list is not empty. So if the list is empty, set the previous pointer of a new node to null pointer, because empty we are just going to insert a new node. So next, update the header pointer of the point to the new node. So process is very simple. So if the list is not empty, first if the list is not empty, then what we have to do is traverse the list from starting. So from head to last node. Okay. So after traversing, set the pointer of the last node to point the new node, because we are going to insert the node only at the end. So next pointer we are included the new node. So previous pointer we have to point the last node. So this is the difference in insertion at beginning and ending. So it is just a simple process. We have to correctly point the next and the previous node. If we done it correctly, the new node will be inserting at the end. So next method is we are going to insert a new node at any specific position. Okay, or in between any 2 nodes we are just going to insert. So there comes a point, if we are going to insert a node in first position, if the node is going to insert at the first position, that is if the position is 1, the same method of insertion at the beginning will be repeated. That is, first we have to create a new node and make it the head of the linked list and return it. So the first point on the first node will be inserted at the position 1. So if we want to insert a new node in any other places, that involves some step, because if, here in this diagram, let us see, we are going to include the node number 3 in between node number 2 and 4. So we have to what we have to do is we have to disconnect the connection between 2 and 4. So the pointer pointing to 2 and 4 will be disconnected. So previous node, next node, the pointer will be disconnected. So first we are going to include a pointer 3 in this diagram. Okay. So in this diagram, what we are going to we are going to include the node 3. So what we have to do is, if the position is valid, then create a new node. So what we have to do is update the next pointer of a new node to the next of the current node and previous of the new node to the current node. That is, the new node, previous and next we have to update with 2 and next with the 4. So after updating the current node, so current node will be now the current node will be new node. So if a new node is if the new node is not a last node, because we are going to include this node only in between. So this is not a last node. So what we have to do is, if the new node is not a last node, update the previous pointer of a new node next to the new node. Look at the arrow mark, you can see, because what we have done is, with the new node number 3 we are going to mark the previous node to the node number 2 and next node to the 4. That is, that 4 number node data containing the node 4. So previous pointer will be pointing to the data. So we have included the data at the position 3. Okay. So these are the 3 methods of inserting, that is at the beginning, at the ending, or at any specific positions. So the same process, next we are going to see about the delete operations. So deleting also the same process, we can delete at the beginning, or we can delete the data in ending, or we can delete the new node or existing node in between or any specific position. So these operations also include some process or steps. So what we have to do is, first for deleting at the beginning, first we have to check whether the list contains the nodes or not. So check if the list is empty. If already the list is empty, then there is nothing to delete. Okay. So next what we have to do is store the header pointer variable. First we have to create as a temporary variable. Okay. So what we have to do is, first update the head of the linked list node to the current head, that is head to the head next. If the new node is not null, update the previous pointer of the new node to null. So if you change this process, then we can delete the node. This process is simple because we are deleting the node only at the beginning. Just we can disconnect the connection between the first and the second node. So the process is simple. So next type is deletion at end. So for the same process, deletion at end, first we have to check whether the list is empty or not. If empty, there is nothing to return, we can leave it. If the list is not empty, then now we are going to delete the data at end. So we have to move to the last node, that is a current node. So for example, we can consider as a current node. So what we have to do is update the second to the last node next pointer to null. We can see the arrow mark, just a red cross. So we are just we can set the previous to null down. In second node we can see next node as pointed as null. So after pointing this as a null, so next node is not available. So null represents, that is no other node is next to the data 2. So automatically the data containing the node containing a data 3 will be deleted. So after deleting, what we have to do, free the memory allocated for the node that was deleted. This is a simple process. So from ending, deleting at beginning and ending is a simple process, just we can assign as null and we can delete the node. But deletion at the specific position is little tricky, because we have to disconnect the nodes previous and next node, because we are going to delete the node in specific position. So this might be a tricky one. First we have to, as usual, we have to traverse the node. Traverse the node means we have to visit the node which we want to delete. So the deleting node will be considered as a current node. Okay. If the position is valid, first we have to adjust the pointer. So if the current is not the head of the linked list, we have to update the next pointer of the node before current to the pointer, because we are going to disconnect the link of the previous node and also the link of the next node. So we have to set the pointer correctly. Look at the diagram, you can see first is a header. So the next position we have to set it correctly, but in last also we have to set correctly, because we are going to delete the content in the middle. So the first and third node we have to connect properly, so that the number 2 node will be deleted. So as usual, if the current is not the last node of the linked list, update the previous pointer of the node after current to node before, because the previous node, because last we are having only 3 nodes. So as a node 3 we have to set next as a null, because no other node is not there in the list. Okay. So after deleting, we have to free the memory allocated for the deleted node. So these are the operations we can do in the doubly linked list. So next, advantages of doubly linked list. What is the main advantages? We can efficiently traverse in both directions. That is, we can move from starting to ending or from ending to starting. Okay. So insertion and deletion of the nodes can be done very easily. So next we can easily use it to implement stack and queue. Main disadvantages is it is compared to singly linked list, it is more complex because we have to make a pointers correctly so that the other nodes will not be get disturbed. So simple complexity is higher than singly linked list, and more memory is required because we have 2 nodes. So memory space will be more occupied. These are the operations and the basic process that we can do in doubly linked list. And thank you for watching.